Up here we have an example of two triangles that we are saying are similar. We can see that by what's written. This says triangle ABC is similar to triangle DEF. We know that means they are going to have the same shape, but not necessarily the same size, as we can see from the pictures that are drawn. Now we have some information that is given to us in these pictures, some of it that is not. Let's write down what we do know. Focusing first on the angles, we can see that we know angle A is 40 degrees. We know nothing of angle C, we know nothing of angle B. On our second triangle, we don't know D, we don't know E, but we do know F. F is 120 degrees. If these two triangles are similar, we know that they're the same shape. It's been said before that same shape means you need to have the same angles, as long as you're dealing with corresponding angles. We're not going to say that angle A is the same as F because they're not corresponding, but we can say that angle A is the same as angle D because they are corresponding to each other. So we know now that angle D must be 40 degrees. If we know F is 120 degrees, we should know its corresponding angle on our previous triangle. F corresponds with C. So if F is 120 degrees, then C must also be 120 degrees. That leaves B and E. We don't know either of those angles, but we do know that they are corresponding to each other. So if we can figure out B, we can figure out E, or vice versa. One way that we can figure this out is to use some prior knowledge. We know that the sum of the interior angles of any triangle is 180 degrees. We know two of these angles. That should help us get the third. We have a 40 and a 120. That gets us all the way up to 160 degrees. We know the total needs to get us to 180, which means the missing piece must be 20 degrees. We can see that all three angles, A, B, and C, do add up to 180 degrees. D, E, and F have to be the same angles. They both have to add up to 180 degrees. Because B is corresponding to E, we also know that E must be 20 degrees. That's what we can tell about our angles. Let's figure out what we can see about our side lengths. We know that with similar figures, we have the same shape. We can see that here. We don't necessarily have the same size, but we are going to be focusing on corresponding sides. We know that this hypotenuse is 13 inches. It corresponds with X. We don't know X yet. We know that this side is 24 inches. We don't know what it corresponds with either. So we need to look to our bases. Our original is 4 inches. Our new is 12. We know both pieces of information. Therefore, we should be able to figure out how they relate to each other. 4 got bigger by a scale factor of 3. Because 4 times 3 gives us 12. We can think of it in the reverse order as well, saying 12 became 4 by dividing by 3. Because they are similar figures, we know that corresponding sides are going to relate to each other in the same way. So if this increased 3 times, that means this must also increase 3 times to become X. 13 times 3 will give us a total value of 39 inches. So we could say that side length DE is the original 13, 3 times larger, for a total of 39 inches. The one we don't know now is Y. This time we know the bigger and would like to get the smaller. So we're going to need to use the scale factor in reverse from going to big to small. So we can say that BC is its corresponding side length reduced by the scale factor of 3 for a final of 8 inches. And here we can see, from knowing just a little bit of information, everything that we need to know about these two triangles.